Okay. Okay, so for today's course, we will have some review. Okay. And how about yesterday quiz? Do you think it's okay? I have checked, maybe not all of you, maybe 60 to 70%. I have checked. A few will not really that good. I think a lot of you getting 70, yeah, around 70, 80. Some getting 90 to, I think some also get 100. And that's, I think, okay for the quiz. But mostly, uh, some still have difficulty to differentiate between the volume, the disk method, and the shell. How to use those methods. Okay, I will show you maybe at the some examples later. Uh, some questions from late yesterday, but we will go through one by one. I've prepared some question, and we can check whether we understand or not. Okay? And I'm sorry I came late today. I just had a meeting before. So let's just check our knowledge on the arc length. So this is the question. The answer is just one correct answer. So find the length of the curve, and you have uh, the equation is y equal the integrations, and it has the square root of p cubed minus 1 dt. So as you can see from the curve and the arc length, this will tell you that you might need the fundamental theorem of calculus, right? The fundamental theorem of calculus, which is you need to derive this y, because in the arc length formula you need to have dy over dy, or the y prime. Okay, so let's just check whether you can use your arc length formula from last class on Tuesday. Okay, and see if we can solve this problem here. Okay. Let me give you maybe 5 minutes to check. Yeah, what you need to do is you can check the formula, okay, and then you just put in all the information here to that formula. And for students who are joining online, you can also check, and you can write the answer on the chat box. And what do you think about the answer? A. Okay, good. Anyone got A? The same answer? A? Not yet? Yeah, fundamental theorem of calculus. You just uh, check the integral. What you need to do is you put this x inside the t, and then you need to don't forget the chain rule this. Okay, but this since it's just x, then the chain rule is just one. Right? Okay. So first, okay, we may need to review a little bit the chapter 5, that is the fundamental theorem of calculus. Okay, so the fundamental theorem of calculus, which is the if we have y, then you will have dy over dx, or if you can just write y prime like that, the same. This will result in x cubed minus 1. Okay, and actually if you want to write completely, just to make some uh, point, and since this is just 1, so we are having just this part. Okay, and the arc length is from, okay, from 1 to 4. Okay, so 1, 4, and still we have the square root of 1 plus, this will be the, you can write y prime or dy dx, y over dx squared, and then dx. Okay, so we will write this, because it's squared, we will have x cubed minus 1. So basically, what we have here is just x with power of 3 over 2 dx. So we just need to integrate this, and I think the number is not too complicated to solve. So we can have this become 5 over 2, 2 over 5, from 1 to 4. It's 4, 5 over 2 minus 1, right? 4, 5 over 2, this will be 64 over 5 minus 2 over 5, right? And this will be 62 over 5, okay? Okay, I think as a just a as a warm up for today's topic. This, I think, not too difficult, right? Okay. Okay. So whenever you see from the questions that has the curve, but the curve has integral, probably you will need some fundamental theorem of calculus to solve it. Okay. Okay. Mostly. Okay. Uh, yeah, this is the same. Okay, before the next question that I prepared, maybe I'll review some parts of yesterday quiz. Okay? I think I'll start with the first one. You have tangent. The second curve is 2 sine x, right? And the interval is from negative pi over 3 x, and then pi over 3. Okay. Now you need to sketch from this interval. Oh, sorry. Sketch the graph. Oh, sorry. Okay. What else do we have? I think we can just sketch it. I think we can sketch. I think that will be the y equal to sine x. Let's say this is pi over 2, so that this will be equal with 2. Okay. Now the tangent at pi over 2 and negative pi over 2, it will have an asymptote. So let me just draw like this. Yeah, more or less like that. Yeah. And of course, I think you can also check that this is obvious that at this interval, negative pi over 3 and pi over 3, the curve is having an intersection. Uh, maybe here. Yeah, my graph is not really proportional, but it should be intersection at pi over 3. Okay? And then we need to find the area between these two curves. Okay. The first method, we can think and slowly take this as area 1 and area 2, and take this integral. So the first one is tangent minus 2 sine x. Okay, this is a1, and a2 will be from 0 to pi over 3 of 2 sine x minus tangent x. Okay, and I think some of you still have difficulty on, let me just write the tangent x here, right? So the best way to approach this tangent, if you forget, okay? So you can check with take the cosine x for u substitution, and you will get this will be negative sine x, okay? And this will turns out to be integrations of negative 1 over u du. So we will have negative ln u, or in our case is the ln cos x. So we can use this integral of tangent, the ln, negative ln cosine x, as our result on the area. Okay. So you can get the total area by adding these two integral, these two area. Okay. However, okay, if you look on these trigonometric functions, okay, this two is identical, right? So you can just using one of each this and multiply by 2. Okay? So you can write down that because of the symmetry, that you can have the area is 2, and if you check the result, this should be the same result. That is, this will be 2 minus ln4, or 2 minus 2 ln2, or 2 plus 2 ln half, right? or at least these two. Okay. Yeah, or maybe 2 plus 2 and half, right? The answer. Okay. Uh, I think half or maybe 60% of you uh, approach the correct one, but the problem is in the process. I think mostly, especially this tangent. Okay, some of you may be confused with tangent and become the secant squared. Okay, that's the derivative. Okay, that's the derivative. Okay. 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 The other one that uh, some students still not sure on how to process is, I think, the number three. Number three. If you remember the questions, let me write the question for you. Okay. So I will leave these calculations to you. Okay. And use the ln cosine x for the tangent. You will get these results. Okay. At least these three results. Okay. Okay. The number three is, let me. Uh-huh. Number three is, oh yeah, the curve is 4x minus x squared, right? And then you have y equal x. Rotate about y-axis, right? Mm-hmm. Yeah, yeah, I think that's the question, right? Okay, if we take the x outside, then we'll have this factor, so we can draw. At least you know this is the y equal x, and you will have the 4 and 0. Okay, at least maybe that's how it looks like. Okay, this will be the 4x minus squared. And the questions is volume on this region when you have the rotations on y-axis. So this is the rotations. Okay. Now the problem when you rotate this, okay, if you use the dy, you will see the problem here. It has its own curve, right? If you let me draw for you, okay? Let me draw for you. If we have the, let's say this method, okay? If you are going to use this method, you need to have all equation in y, right? And we are going to, at least this is the problem here. From the bottom, from the bottom until this point here, the area here is no problem. You know that you can, this curve here, the blue color minus the green color, right? But here, what will you subtract? That's the problem, right? And that's why this method fails here. Okay, so the better way is we can just using the shell method. Let me erase this. Let me erase this, and we can take the approach using the shell method, and this will be how it looks like. Okay, so we will have the x up here on this rectangle. Okay, so when we rotate, our concern is really just to find the radius and the height. Okay, the radius is just x. Okay, because we can set up with different x, and the height will be the difference on this two curve, right? The two curve. Okay? This height. So the height will be, let me write here, the height will be 4x minus x squared minus x, or 3x minus x squared. Okay? And the volume will be, or if you want to find the intersection here, we can make sure that this equal x. Then this will be 3x minus x squared. And we will have at x equal 3. So these integrations will be 2 pi, integrate 0 to 3 and x, and multiply with the 3x minus x squared, and then the x. And then multiply. This is 3x squared minus x cubed. And we can have this x cubed minus x with power of 4 divided 4, and plug in 0 and 3. So we will have 27 minus 81 over 4. If you just finish up until here, maybe you feel you need time for other answers. I consider this as a full point, okay? If you just end up until here. But if you want to calculate, I think you can make it under 4, and this will be 108, and you will get 27. So it will be 27 over 2 pi. Okay. I think, yeah, most students, these two questions I saw not really sure on how to solve. So that's how. So whenever you find the rotations on finding volume, okay, always check and always see whenever this case happens. Okay, if this happened, then you need to switch to the shell method. Okay? The only way to solve is shell method. Okay, I think the other number is, I think, okay. Most students, you answer correctly. Okay, let me check. Okay, let's go to the next questions. I prepare another one here. Okay, let's check this question here. Let me give you a couple minutes, maybe 5 minutes to check. You can check your notes. And online students, you can also check and try to figure it out. Okay, anyone find the answer? Okay. Carry on. It's yeah, okay. Okay. Let me check. Okay. B. Okay. You fine? Oh, you fine, Paul? Not yet. Okay, okay. Okay. This one, okay. You see the x squared and also x squared inside, and it has one minus, right? So if you check using some substitutions, uh, you need to think on how to substitute this variable, right? If you want to substitute with the just regular u, it still have some x left when you try to convert to u. And I think it's better to use the trigonometric function. Okay, one minus, so you can have cosine or sine. Okay, well, let's just use the sine. Okay, because if we derive, it will be a cosinus, which is positive. So let x is sine theta. So your dx will be cos theta d theta. Okay, and when we are convert this x to theta, then we need to also convert the endpoint or the interval of integrations. Okay? So when x is 0, theta is 0 based on sine 0, right? And when x is half, then theta will be sine that resulting half will be pi over 6 at least, right? Okay. Okay, so we can rewrite the integrations from 0 to pi over 6 at least. And then x squared, this will be sine squared theta. And over, you have 1 minus sine squared theta. And the x will be cos theta d theta. This will be resulting cos squared theta. And cos squared will be cos theta because of square root. And you can have cancellations between these two. So there's this resulting in sine square theta d theta, right? Okay. Now, remember that whenever we have squared on sine or cosine, the best way to approach is we are using the double angle formula. Okay. Let me just write the formula, the whole formula for you. The basic formula is from cos squared theta minus sine squared theta. Okay. You can exchange cos with 1 minus sine squared, or 1 minus cos squared for sine. Depends on which you are going to replace. Okay, and in our case, we are going to replace this become 1 minus 2 sine squared theta. So sine squared theta is half. Okay, 1 minus cos 2 theta, and we are going to replace this to our integrations. So our integrations will be 0 pi over 6. So this will be half minus cos 2 theta over 2 and d theta. This will be resulting on half theta and minus sine 2 theta over 4 from 0 to pi over 6, right? So this will be resulting in pi over 12 minus pi over 6 is will be sine pi over 3, right? So this will be pi over 3. Sine pi over 3 is, we can have, which is b. Okay, it's the same. Then sometimes we'll have also uh, questions like this. So it's combinations from some chapters, and you may need to have some knowledge on list limit concept, especially from the how to use the L'Hopital rule. Okay. But this is related to this fundamental theorem of calculus on chapter 5. Okay. Anyone got the answer? Okay. Anyone got the answer? B. D. B. Equal 1. Okay. Anyone else? D. Okay. Okay. The last one is the correct one. Mhm, mhm. Okay. If I write like this, is anyone has a solution? This is the same as this, right? Okay. When you put the 0 inside here, it's 1, 1, it will be a 0. You put here is also 0. So because of the 0 of 0 situation, you can use the, or you apply L'Hopital rule, in which you can derive this and this, okay, each one. So each equation you can derive. You derive the first one, the integral, which requires the fundamental theorem of calculus, and this x will be equal 1. The bottom one is just 1. Okay. I think we can focus on the top equations, okay? Because that's the main integral problem here. So what you need to do first is you switch this first, okay, so that you can apply the fundamental theorem of calculus. You switch this and take minus and write minus. Okay. If you switch the endpoint, then you need to write down the minus. Okay. So this you can write as and you can write apply L'Hopital rule. And then apply L'Hopital rule, we put the 1 minus x inside the t. Okay. And don't forget the chain rule. Okay. Because minus, and then in the chain rule, you get also minus 1. So minus minus, so it will cancel. So it will be positive, right? So we can just plug in the 0 inside here. Plug in 0, 0, 1 over 1 plus 1, 1 over 2. Okay. So it will be D. So probably just suggestions whenever you find yourself in exam, maybe you write like it takes time to write some process, and if you think it's too long, maybe you're not in the right path. My suggestion is choose other questions first. Okay, it will be taking much time. You take another questions, and later you go back there and find another way. Find another way. It can help you to manage your time during the test. Okay, I think most of the tests you can take some time to think what strategy that best to solve. Right. I believe some tests sometimes when you have the test, they have like certain points. When you have like a correct answer, you get maybe plus something. And some tests, I think there is also a test that when you have the wrong answer, they will have minus point. If you don't answer, it's just 0. But if you get the wrong answer, you get minus. So it's possible that you will get like lower from your score. That's just another method. Not in my exam. Okay. So when they have those kind of rules, some strategy you need to think. In my exam, if you take sometimes to write some formula or any statement, I consider this as a point. Okay, either it's correct or no. At least you get like point. If it is correct statement, correct process, maybe you get at least maybe 50%, or if no, maybe just 10 to 15. Okay, depends on the total points on that question. Okay, okay, okay. That's uh, the fundamental theorem of calculus. Yeah, this is same. It's my checking my answer. Okay, another one is this one here. There will be more than one answer. Okay, so it should be like multiple answers. Okay, it can be multiple answer. You have um, four integrals, a, b, c, and d. You need to find which one or which of the following. So it can be more than one that are converged or convergent. So the first thing you can do is uh, all these four statements or integrals, they have the infinite interval, right? This infinity, 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 and this is also infinity. The first thing you can do is you need to use the limit to approach those infinity. Okay? And maybe each one of them, you need to evaluate the integral. Okay? The answer may have more than one answer. Yeah. So yeah, it's more. It's probably more than one answer. Anyone can get the answer? The first one is diverse, right? The first one is diverse. Second, converse or diverse? Converse, right? Because of the tangent inverse, right? Tangent inverse of infinity is something that is, and the tangent is pi over 2, at least, right? At least on, right? So it will be converse. This one, converse or diverse? The third one. Yeah, it's also converse, right? If you think 1 over e, this is e with negative, right? So 1 over e, if you take the limit, it will get to 0, right? If you think the infinity. So probably the converse. I think the difficult part is the last one. The clue for the last one is using the comparison theorem. The comparison theorem. So you need to compare this with the something that you can think. Okay. So if I write the uh, let me check. P convergence, C convergence. Yeah. How about D? Okay. How about D? So the D is first to separate this uh, or to understand these questions, we can separate this. And since we know that if we have 1 over x like this, we know, like if we have from evaluation from 1 to infinity. So let's make this integral, separate into two integrals, and divide by 1. Right? Okay, so we can have first is this, and second is 1. Okay. Now, if you look at the functions, we have this, right? So if we just compare this to 1 over x with power of 4, we can, right? Right? Okay. And this is at least, right? At least this. At least if we check here, it is larger than this one. So the right one is greater, right? Okay. And then to check, we can start with this. Check with this, and this will provide you with a converged solution. And you can also try to prove this one also. I think it will be a similar situations with the 1 infinity here. That is, when you have this, then the whole situations become converged, right? Because this is greater than this left. Because it's already converged, the small functions here on the left will be also converged. Okay. So if we take or break down the whole part, okay, the first one is already diverged. Okay, the second one we have a tangent inverse, and we can look at the solutions. The third one also we can have the e, 1 over e, and the fourth one we can look on by the comparison theorem, and you can get that the whole thing will be converged as well. So the three B, C, and D is they are all converged. So B, C, D is converged. If the question is which of the following divergent, so just A, right? The convergent is B, C, and D. Okay, now that's uh, an example on improper integral. Uh, Let me give you a little bit chapter 7 on the techniques. Okay, I think we haven't discussed. Okay, so let me get you to another one. Okay, two questions. I think the first one is doable, and I think not complicated. Mm, yeah, yeah, okay. Yeah, correct, Rian. Okay. Anyone got the first one? Okay. You get the first? Okay. You get for number one? Number one, you get? What's your answer? 1 over 4 secant. Oh, yeah, okay. Mm-hmm. Okay. Okay, okay. Okay. Sometimes in the integral, you will find several solutions. Okay? It seems different, but uh, as long as it is correct, okay, I think that that's still okay. Because remember, if you have integral, the results, if this is indefinite integral, you have the plus constant, right? So the plus constant will be justified by probably you will have different techniques will have different results, and actually they are the same. They are just the difference just in the constant. Okay? So for the first one, the key or the idea is you need to remember that uh, all you need to do is relate this two derivative. Okay. Relate these two derivative. So when you have the, let me put the other one going down here. So when you have the tangent x secant with power of 4, if we try to make it uh, secant squared x and secant squared x, okay, and dx like that, we may have changing the or substitute. Okay, the secant squared also the important one is the tangent squared x plus 1 is secant squared x. So we may change the secant squared to tangent squared. So this will result in okay. So if you check the tangent and change to u, you will have the secant squared x dx. And you will cancel this part here, right? So you will have integrations u squared plus 1 du, or this will be u cubed plus u, or we can have 1 over 4. U is a tangent. Uh, tangent or x plus 1 over 2 tangent squared x. This is plus c. This is the first answer with this method. Okay. However, okay, if you look again, let me write another one. We can also write this as secant cube x secant x tangent x dx. We can have this secant x tangent x, right? And we can substitute. I think this is a very short, the second one. We can have u as secant x, and the u is secant x tangent x dx, which we can cancel the secant x tangent x, right? So we will have this is equal integration of u cubed du. Okay, and by doing this, we can have 1 over 4. This is secant with power of 4x plus c. And that's why I told you before, this two answer is correct. Okay, this two answer is correct. What's the difference? The difference is the c and the c is not the same c. Okay, that's why every time you integrate the indefinite integral, you need to write the plus constant. So we have two results. That it seems different, but it's actually the same. It's actually the same. Okay. Okay, that's the number one. Okay. So whenever you choose which method you prefer, those two are fine. Those two are fine. Okay, the second one. The second one is a little bit, I would say, tricky. The answer is quite long. But the first clue is separating this into a partial fraction. Separate the whole functions become partial fractions. Okay, become separate functions. Okay, but you will have a difficulty, I think, in this quadratic function here, right? Okay, check. Stuck. Okay, so let me give you the first step. The first step to check is let me write in the new page. Okay, let me cut this and write in here. Oh, let me write another one. So we are not confused on the integral. So we can separate the functions first. So this is x plus this whole x squared plus 2x plus 2. This is a bx plus c. Okay. So we may need to find a, b, and c. So I think we can try to find. So first is we can compute this and equaling this to the results here. Okay, I think we get a is 1, right? So 2a is equal to a is 1. A plus b is 0, so b is negative 1. And 2a plus c is 3. So 2 plus c is 3, so c is 1. Right, so 1 minus 1 and 1. So we have the solutions for the partial fractions is negative x plus 1. This is x squared plus 2x plus 2. Okay. Now the problem is we need to integrate this. So integrate, give the x, integrate, give the x, integrate, give the x. Now this is, I think, the partial fraction is okay. The difficult part is the last integrations here. The first part, 1 over x, is we can write just ln x like that. Let me just write this first. Okay. Okay, now what can we do to solve this? It's a little bit tricky, but we can solve this with substitution. But it's a little bit tricky substitution. So the top one is minus x plus 1. Okay. The bottom one is x squared plus 2x plus 2. What can we do here? Okay. If I give you this, okay, can I factorize this, the bottom one? No. But can we use some standard for complete standard for factorization? Okay. If we have x squared plus 2x, it should be plus 1, right? Okay. So let's do that. This is will be x plus 1 squared. So plus 1. Okay. 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 Now we have x plus 1 squared plus 1 for this bottom part. Okay. Okay. Now if we can take this in terms of, let's exchange this in terms of u. Oh, my pencil is need to charge for a while. Okay. So let the x plus 1 become u. Okay. Then the top one we can also exchange to u. Right? We need to plus something to make it equal. And at least we can have some more simplified than this one. But still, we need to think how to solve. Let me check. Okay, still can wait for a minute or two. Okay. Now let u is x plus 1. Okay. So the negative x will be negative u plus 1, right? So we can have this become plus, and du dx is just the same because it's just x. X is dx, du is equal dx, so no problem in the derivative one. This will be negative 1 plus 1 plus 1, so plus 2. Okay. The bottom one will be u squared plus 1 du. Okay. Now let's separate this. Let's separate. Okay, let's separate. Can we solve this? I think we can, right? The middle part, we can use just a substitution one more time. One more time substitution. We can substitute this u squared plus 1, right? Substitute this, and then you can cancel this part, right? Okay. And this last one, we have the tangent inverse. Okay. So with some little bit tricky substitutions in here, we can solve the question. So let us write. This should be equal with. Let me write on the right. And let me write. So this will be equal ln x. This will be equal negative half because let me write this is it will be having a half, right? So half and then ln because 1 over z, and this will be u squared plus 1. This is plus 2 tangent inverse u, but let me solve this to x. This will be x squared plus 2x plus 1 plus 1, so plus 2, plus 2 tangent inverse x plus 1, and then plus c. And this will be the answer. Okay, I think for today, I will stop until here, and I will prepare another questions for you. Hopefully, I can give you some from last year final exam. Um, I can also put into the Google Classroom so that you can see the questions and maybe have some exercise. And next Tuesday we can have some discussion on those parts. And next Tuesday we will have just online class. Okay, just an online class. Okay, so you don't need to come to the class. And for the class for the final exam, I will announce later. I think not in this class, maybe in another building, maybe in IB, more space. Okay, so we can have more space. I will announce this week for the final exam class. Okay, I think that's it for today. I will stop the recording. If you have any questions,